Welcome to the Swine Nutrition Black Belt Podcast, the latest swine nutrition research digested for you. I'm your host, Clayton Chastain, and today we have with us Ty Mitchell, an undergraduate research assistant at Texas Tech University. So Ty, before we get started, would you mind giving the audience a short introduction about yourself?
Yeah, well, thank you very much for having me on here. I'm pretty lucky to be an undergraduate researcher and be able to come speak on this podcast. A lot of people that I look up to and people that I'm learning from are featured on here, so it's really an honor. Well, my name, like you said, my name's Ty Mitchell. I'm from New Mexico. My family's in Albuquerque, New Mexico, and so I grew up in southern New Mexico, involved in agriculture and stuff, and so I study animal science here at Texas Tech. I have a minor in chemistry, and just luckily, I got involved with undergraduate research. I work for Dr. Amy Petrie here, and wow, that's been the experience of a lifetime. My growth in the last year has been huge. I've gone from, just taking a part of a lot of master's students projects in our lab group to working on this project that's I've been able to put my name on it and get to do a lot of the work with Dr. Petrie. So that's kind of where I'm from and what I'm doing here at Texas Tech. I graduate in December, so I'm eager to go to grad school and to continue on. I really like working in this research field. It's certainly a passion of mine and seems to be a fit. So excited to be here.
Yeah, awesome. Yeah, we're happy to have you here too. So let's talk about that recent presentation that you gave at Midwest. It seems to be looking into testing the possibility of utilizing trained immunity in the prenatal pig. Would you mind telling us a little bit about that study?
Yeah, certainly. So the trained immunity study was between myself, Dr. Petrie, and then research scientists at the USDA ARS, the Livestock Issues Research Unit here in Lubbock. And so that took part with Dr. Sanchez, Dr. Carroll, and Dr. Broadway. And so as I kind of introduce this, I want to start with just some things that we know and some givens that kind of helped us formulate our research question and led us into, exactly what we want to study. And so, we know that stressors in early life are, such as weaning, they likely dictate health in later life. And so we know that the stressors during weaning, such as stresses to the intestinal tract, immunological changes, behavioral changes that occur during weaning, that are a result of, commingling with other pigs or pathogen exposure or dietary changes. These are all things that place great strain on the weaned pig. And so in order to, maybe modulate this immune system so that at the time of weaning, when they're faced with all of these stressors, they might be able to have a bolstered immune system. We studied into the phenomenon of trained immunity, which is the functional reprogramming of innate immune cells that's evoked by an endogenous insult that leads towards an altered response towards a subsequent challenge. And so Dr. Carroll and Dr. Broadway and Dr. Sanchez, they had prior experience doing a lot of this trained immunity work in beef cattle, and they've seen, really incredible results there. But largely uninvestigated in the pig. And so since Dr. Petrie and I work with a lot of swine here at Texas Tech, that's where we collaborated together and started with that research. And so, a lot of the questions that we were asking was, can an immune system challenge in utero be used to bolster the immune system rather than hamper? We know that classically the perinatal period, which is defined as the end of gestation up to birth and then thereafter. That time period, it has a high level of plasticity in terms of development. And so it's been widely cited amongst the literature that stressors during that time period negatively impact, postnatal immune function, post-performance. We've seen a lot of studies, whether it's a dietary imbalance in utero can cause problems later down the line. We can see, a lot of that work support that notion. But because of the developmental time period and the adaptive responses that are taking part in early life, we ask the question, well, can this be used to bolster the immune system rather than hamper? And so what we did is we took 14 Canberra sows at day 78 of gestation, so in that last third, and we inoculated them. We blocked them by weight and randomly assigned to a treatment. And 7 of the sows got an LPS, an intramuscular injection of LPS, and then 7 sows just got an intramuscular injection of saline. And so during this 48-hour LPS challenge, we took a rectal temperature and a sickness behavior score at different time periods throughout that 48-hour challenge. And then we followed these sows through gestation up to parturition, to where we took a subset of their weaned barrows, and barrows that were from both the LPS and the control sows. We took a total of 34. And we brought them to the facility at the USDA, which is where we got to work heavily with the Livestock Issues Research Unit. And on day -1 of the piglet trial, all of these 34 barrows, they were anesthetized, and they were placed for a subcutaneous temperature logger and a catheter. And then on day 0, all 34 of the barrows were challenged with the same strain of E. coli, or of LPS, the E. coli 011b4, at 10 micrograms per kilogram of body weight. Similarly, we took body temperatures, blood samples, and sickness behavior scores at time increments. And then at the conclusion of the 48-hour LPS challenge, all 34 barrows were necropsied for ileal and jejunal samples. And so, as we get into the results, that kind of just explained the experimental model and some of the protocols that we saw. But some of the first data that we accrued was the sow data that showed that, we had a mild immune response, and so we were able to confirm that dosage was correct. But interestingly, one of the neatest things that we saw was that the subcutaneous temperature in pigs that were exposed to prenatal LPS was higher than the control pigs at hours 1 and 2 post-challenge. And so we saw the typical, the increase in the fever response post-inoculation, and then that returned to baseline at about 24 hours. But what we saw was that the pigs that were exposed to prenatal LPS, they had a greater febrile temperature earlier at hours 1 and 2. So that was some pretty interesting data. We also saw, from an oxidative status standpoint, we saw reduced levels of malondialdehyde, which is a measure of lipid peroxidation. We saw reduced levels of that in the jejunum and the ileum. And also, to study cytokines and proteins, we did a 50-plex immunofluorescent biomarker assay that showed us jejunal and ileal homogenates. And some of the interesting cytokines and proteins that we saw there, we saw, an increase in stem cell factor in both the jejunum and the ileum. Well, stem cell factor plays a role in innate immunity through its recruitment of mast cells, or its effect on mast cells. And so that's pretty interesting. We also noticed in the ileum, pro-inflammatory cytokines such as tumor necrosis factor A and interleukin-6. They were raised in the jejunum and the ileum. And so, these are all signs that the immune system of piglets and the oxidative status of piglets post an LPS challenge in utero, they have a modulated immune system. And so we're seeing some differences. And although very much in a preliminary study, it's exciting to see the differences that we did and some of the data that we're still studying.
Awesome. So I was looking at some of that data, and that it was one of the interesting parts was, and you mentioned it a little bit already, of the decreased malondialdehyde in those challenged pigs, and also there was like that decreased total antioxidant capacity. So could you maybe dive in a little bit to that and kind of help explain those results a little?
Yeah, and honestly, I'll be honest, that's something I'm still learning, and it's a little bit challenging to explain. But I know that malondialdehyde is a measure of lipid peroxidation from the T-bars assay, and total antioxidant capacity is a measure of total antioxidants. And so ultimately, these two are inversely related. And if we see a decrease in lipid peroxidation, like we saw in the jejunum, then we should see an increase in total antioxidant capacity. But we ultimately, in our data, showed the decrease in MDA and lipid peroxidation in the jejunum, but we also saw decreased TAC, and so kind of challenging to explain, but I know they're just measures of lipid peroxidation and total antioxidant capacity.
Gotcha. And so with this kind of research, you mentioned that this is kind of like the preliminary research in this kind of phenomenon. So what would then be like the next steps for the team at Texas Tech? Do you plan to do like maybe looking at longer studies and seeing more growth performance factors, or what do you think is next there?
Yeah, I think there's a lot of possibilities that we could go with this. And like I mentioned, this is certainly very much preliminary data from the piglet side. And so I know there's an interest in meat science, whether prenatal immune system stimulation affects, muscle hypertrophy and hyperplasia. So further studies looking at that from, maybe a carried out growth performance study to 280. But from our perspective, studying the immune system, I think we could take a lot deeper look into how the adaptive immune system plays into this study as well. I think that would also be interesting. And I mentioned stem cell factor was raised, but unfortunately, we don't have a number on mast cells, and so I think that connection between those two would certainly be interested. But definitely further research is warranted because the concept of trained immunity, we need to further elucidate that mode of action that's happening maybe in utero to the piglet, and so there's a lot of potential here and a lot that we can go with in the future.
Yeah, I feel like there's a lot of different directions that this could be taken.
Yeah.
But,
certainly.
Yeah, and so, well, I think that's all the time we have for today. So I thank you for, again, for coming on the show and sharing all this research with us.
Yeah, well, thanks for having me. It was great. Appreciate it.
Yep, and to everyone else, thank you for listening to the Swine Nutrition Black Belt podcast. Please visit us at swinenutritionblackbelt.com, and don't forget to subscribe to our podcast channel so you won't miss out on the next episode. See you next week. Hey everyone, I hope you enjoyed this episode, and we are constantly on the lookout for the latest updates in swine nutrition. And if you have a swine nutrition related research trial that you would be able to share on our podcast, please send an email to nutritionblackbelt@swineit.com, and we would love to talk about your research. See you later.